Hey, don't go too far! Now that we have units walking on top of the grid, it's time to limit their movements a little bit. Because in the end, the unit is only going to be able to walk depending on how many movement points it has. But right now, there's nothing preventing it from going from one side to the grid all the way to the other. So that's why we're going to integrate that today, so let's get to it. But before jumping into the real subject of the video, there's actually something that I wanted to fix for a little bit, and I always forget to do it. So I'm just going to do it right now so we can stop thinking about it. And it is in the debug menu, in the actions, and it is the button underscore action, and it is inside the graph. So let's go in there. And right here we have this little bit of code that tells us if the button is selected. So what I'm going to do is just collapse that inside a function so we can reuse it in the other button. So collapse to function. I named it isCurrent selected action, and I will make it a pure function just like that. Now I can bring it closer right here, and I'm going to replace the nodes right here at the bottom just like that. Now we can compile and we're done with the button, so we can close. And now what I want is to use this new function inside all the other buttons that we created. So I'm going to select all of them, right click and click on edit, just so the editor opens all of them for me. And for all the widgets, what I want to do is go in the graph and insert the new function right here before the cast. So I'm just going to paste it right here. So I'm doing a branch to make sure to execute the code only if the current button is selected. And if not, I'm just going to hide everything just like that. And I'm actually just going to move this visible right before the cast also, just so it's going to be a little bit cleaner. Just like that, so I have my visibility first and then I have my cast and all the logic of the button. It doesn't change the behavior of the button itself, it's just a little bit cleaner in my opinion. So now I'm just gonna go do the same thing in all the other widgets. So right here, I'm gonna go in the graph, paste my condition right here before executing any of the logic, and then shuffle things around a little bit. I'm just going to show you some screenshots at the end because I don't want to go through all of that with you because I think you're able to do it by yourself if you want to. Here we go. So this is a button action add remove unit from combat. Button underscore action underscore calculate min cost. Button underscore action underscore find path to target. Button underscore action underscore increase decrease tile height. Button action set tile type. Button action move unit on grid. And finally, button action show tile neighbors. Here we go, we're done. But why did we do that actually? There's two reasons. First, I think it's cleaner, it makes more sense, it's better, that's just better. But the real reason is because the casts are not enough in that case, because let's say you have two buttons. Both buttons are using the same action for the left click and a different action for the right click. In the case that we have those two buttons in the user interface, and if you select one of those two buttons, the second button is also going to execute its logic associated to the left click action, because let's say you have just the cast right here for the left click action, it's not enough because it's going to think that the selected action for the left click is the right one, which is the case. The selected action for the left click is the right one because it's the same action for both buttons, but it doesn't mean that we want to execute that whole logic every time we are selecting a button that uses the same action as the other button. In the case that we have different parameters, that's not what we want. So that's why we have to check at the beginning right here if both actions correspond. Otherwise, it's just going to break in the case that we are reusing some action on another button. I don't know if that makes sense. I don't know if I explained it well, but just trust me, it's better with that. Anyway, it's now time to do the real logic, so we can close all that and go work on the real thing. So to limit the unit movement based on the amount of movement point it has, there's actually two steps we have to do. We have to first generate the list of reachable tiles based on that amount of movement points, and then we are going to use those tiles to limit the movement of the unit to those specific tiles. So let's start with the first step. We have to generate the reachable tiles, and to do that we're just going to add a new parameters inside the action that selects a tile, because we are going to select a tile to get ready to draw a path, but at the same time as doing that we're just going to display the reachable tiles. So let's reopen the button action find path to target. In the designer, I added a new spin box right here for the length of the path. I named it length. My min max value are -1 and 999999999, just infinity. And then I have the slider -1 to 30, then the value is 10 by default, and then for the frag digit is 00, delta is always true, and then the delta is 1. And now we can just implement the event in the bottom right corner, just like that. We can just connect it like so with the other ones and then go feed the value to the action right here. But now we don't have a variable, so I'm just going to go open the action. So here I have my action find path to target that I'm going to open and create myself a new variable. It is going to be of type integer for the path length, and I'm going to name it max path length. Now we can compile and go back in the widget to assign it right here at the end. Just like that, so we are taking the value, passing it into the variable, but this variable right now, it is for the action find path to target, so it's only going to be taken into account when we are generating the path itself, not when we are selecting the tile. And we don't actually have an action to select the tile right now. If we go back on the button, we can see that the action that it is used, it is the basic select tile and unit. So what we're going to do is create a second function to select a tile and a unit, but to also generate the reachable tiles at the same time. So I'm just going to go in my action and I'm going to start by duplicating that one. Actually, no, we don't want to duplicate it. We want to create a child from that class because we don't want to just duplicate the code for no reason. We can simply create a child from it. So I'm just going to right click on it, create child blueprint class. I named it select tile and unit and generate a reachable, and I'm actually just going to move it inside the pathfinding folder, just like that. Move here. And now we can open it to do the logic. So here let's start by creating a new function to generate the reachable. So I'm just going to name it generate a reachable real quick, like that. And I'm not going to do the logic right now, but we can go call it, and we are going to call it inside the execute action function. So we can just override the execute action right here. We still want to keep the parent, so I'm just going to reconnect it properly, just like that, because the parent right now, if you check in the top right corner, it is the select tile and unit. So we are selecting the tile and the unit right here. And then once that's done, we can generate the reachable. So we are going to call the new function we just created. And back inside that function, it is going to be pretty similar as the find path to target because the process is pretty much the same. So I'm just going to recreate all those variables right here. So I'm going to go back in there and create all the variable I need. Just like that. So now I have a boolean for include diagonals, boolean for flying units, and then two floats, one for the delay between iteration and one for the max ms per frame. And then I have the max path length that we just created. So it is an integer, and I'm going to go back inside the button to assign those variable right here. At the same time, we are assigning the ones to the action right click. Oof. It looks messy, but I guess it's not too bad. Here I have all my new variables assigned to the new class that we just created right here. But right now the selected action left click, which is the one I'm using for the cast, make sure to use the left click instead of the right click. Right now the left click, it's not the right action it is using when we are clicking on that button because we never assigned it inside the designer. So I'm just gonna go back in the designer, select my button, and select the new action we created in the left click action right here. So I have the action select tile unit generate path reachable just right here. And one last thing before closing this button, we just have to go back right here because we never assigned the new spin box that we created. So the spin box for the length right here, we never assigned its visibility. So I'm just going to paste it right here to collapsed when it is not selected and visible when it is selected, like the other ones. Perfect. Now we can compile for real and close this blueprint. And now we're ready to start working on the generate reachable function. And actually the logic is not that complex. It's pretty much the same thing as the find path to target function. So I'm just going to go back in the find path to target right here. And inside the execute action, I'm just going to copy all those nodes right here, copy them, and then go back in the generate reachable to paste them like so. And then we can just connect them like so. And now the code complains that the function doesn't exist for the onPathfinding completed, so we can just create a matching function, named it onPathfinding completed, and we're going to do the same thing we did inside the path. So I'm going to go back in the path, go in the onPathfinding completed function that we add over there, and copy all those nodes just to paste them inside the new action like so. And now that we have the basics, we can start modifying it. The first thing we're going to do is the color. So right here I have the color when we are adding a state to the tile, and the color that it is using right now, it is the isInPath color. We need a new color for the reachable, so we're going to start by adding a new color. So in the grid utilities right here, we can open the enum tile state right here to create a new color, which I'm going to name is reachable. Now we can save, close the enum, and go apply it inside the grid mesh inst right here. To add my color at the end of the enum, so right here is reachable, and for the color itself I'm going to select a dark shade of blue, just like that. Now we are done with the grid mission, so we can just compile, save, and close it. And back in the action, we're gonna change the enum for the is reachable and do the same thing inside the execute action, generate reachable right here. We can change the is in path for is reachable. Good, now we're ready to modify the find path function because we're gonna change it a little bit just so it supports the reachable. So let's double click on that to open it. And the first thing I'm gonna do is go back at the beginning to create the two new variable we're gonna need. So new parameter right here. Here we go, so I have a boolean and an integer, which is the return reachables, which is going to tell us if we want to return the path or the reachable tiles, and then we have the path length. And for those two variables, I'm just feeding them into some other variables inside the blueprint. So I have my two new variables right here, so I have my return reachable tiles and also my max path length. And now, what do we need to do to support the reachables? Well, it's actually super simple, and that's actually why I'm not creating a new function for it. We just need to, instead of returning the path at the end, we just need to return the analyzed tile indexes, because if they are part of the analyzed, it means that we are able to walk on them. So that's why, instead of returning the path at the end of the function, we're simply going to return all the analyzed, because we can walk on all of them. So that's exactly what we need to know. And there's actually just two places we have to change something. So I'm just going to zoom out a little bit and go at the end of the function right here. This is where we are returning for real in the case that we are not using a delay between the iterations. So right here, if we are not using a delay, this is where the function returns in the case that it didn't find any path. So what I'm going to do right here is just replace the make array by a select. So just like that. In the case that we want to use the reachable tiles, we are simply going to use the reachable tiles, so the analyzed tile indexes, instead of an empty make array. And now for the second place where we have to connect this, it is inside the event graph right here, and it is right here. In the case that we don't find anything, it's returned an empty array, but in this case, we're simply going to return the analyzed indexes the same way we did inside the function. And the last little thing we have to do to support the reachable is actually inside the is input data valid right here. Because right here at the beginning, we are checking to make sure that the start index is valid and it is different than the target index, which is perfect. That's exactly fine. But then everything at the end is about the target index. But in the case that we are generating a reachable list, we don't really care about the target. Actually, we don't have a target. We just want to know every tiles around us that we can reach. So all that code is not really useful, and actually it will prevent us from doing what we want to do, which is generating a list of reachable tiles. So what I'm gonna do here is move all that a little bit further on the right, and then in between the start index and the target index, I will just add another condition right here. So we're just going to check to make sure that the target index is valid in the case that we are not returning the reachables right here. So if we are doing a normal path, the target is super important, so that's why we are validating it right here. Otherwise, we are just going to return is valid because we don't care about all that stuff. So just like that, we are just going to return valid because we want to generate the reachable, which don't care about the target index. Perfect, we can now compile, and we should now have reachable tiles that work. And now to test that, I'm just going to go back in my action to generate the reachable, and I'm going to check that checkbox, obviously, because we wanted to return the reachables. But the last thing we have to do is to change the target right here. So I'm just going to split it and write minus 99, minus 99, because otherwise the pathfinding will stop as soon as it touches the valid target. But in this case, we don't have a valid target. So the pathfinding will never stop. And that's exactly what we want. We only want the pathfinding to stop in the case that it reaches the end of the length. But right now we don't have the length implemented, so it should work as expected. So I can just compile and go test to see if it works. Select the action and now click anywhere on the grid, so that tile. Okay, good. So it means that the unit can walk on any tiles of the grid. These are all the tiles that are reachable by the unit. Right now we didn't implement the path length, so it means that the unit can go pretty much anywhere. It has as many movement points as it wants. So that works. That works fine. Perfect. There's just one thing that we can see that it works is right here. All those tiles are for flying units only, and we can see that we cannot walk on them right now. And if I check my checkbox is flying unit, we can now click and we can see that those tiles are also included inside the reachable. Here we go. So now the reachable tiles are working. We just have to limit the path length. So let's do that next. And we actually just have two things to change for it to work. So since we are already in the is input data valid, I'm just going to do the first change right here, which is going to be at the end. So I'm going to give myself a bit more space, just like that. And I'm going to make a little checks right here. So in between, just like that, I'm going to check and make sure that the minimum cost between the two tiles, so the start index and the target index, are smaller or equal than the max path length. Otherwise, we're just going to skip the pathfinding. This is just an optimization because we know that we cannot reach that tile with the maximum amount of movement point that we have. Even in the best case scenario that we go in a straight line all the way to the target, we can't reach it. So no bother trying to reach the target because we just can't. So in that case, I'm just going to return false because we're gonna take it as the input data is completely invalid because we can't reach that. And the second little thing we have to change is inside the discover next neighbor function, because we just discovered a new neighbor, so we have a few info about it. We know how far it is from the start to that neighbor tile, and that's exactly what we need. We just need to know if the neighbor is too far from the start, because if it's too far from the start, well, we can't reach it, so it's not valid. We're gonna skip that neighbor. So that's what we're gonna do inside the discover next neighbor. We're just going to check when we discover a new neighbor. Okay, are you too far, bro? Yes, no, that's it. And now if I zoom out just a little bit, actually it's not too far. I think it's just right here. Yeah, this is the cost from start. So this is where we are calculating the cost from the start of the path to that specific neighbor. So just after setting that variable, we're just going to check to make sure that the cost from start for that neighbor is smaller or equal than the max path length. So if the neighbor is too far or not. That's as simple as that. So we can just connect it like so. If the neighbor is too far, well, we can simply return false because the neighbor is too far. We don't care about it. Ignore that neighbor. And now we should be able to test it. So I'm just going to go back in the action to connect the path length. So I'm just going to take my path length and connect it like so. Now I can compile, go back in the level, press play and see if it works. And now if I select my action and click on the grid, here we go. We can see that now instead of highlighting all the tiles on the grid, it only highlights the ones that I can really reach. Here we go. It seems to work. And what if I reduce the amount of tiles? So let's say 2. Yeah. So now I have 2 movement points. So 1, 2, here we go. So it works perfectly great. If I have a longer amount of movement points, we can see that I can reach pretty much everything on the grid. But right here, I don't know why I added the variable -1 inside the spin box. It's not really useful. So I'm just going to go remove that -1 right here. I had an idea in mind, but I just realized that is a bad idea. So we're not going to do it. So let's go cancel that and make it 0 as the minus. Inside the button action find path to target, we can simply select the spin box and set the minimum value to be 0 instead of -1. Okay, good. We can now close it and that's it. So now the reachable are working great, but what if we just right click on the grid? Nothing happened. Okay, that's interesting. Once I did the first right click, then I can move around and highlight everything. Oh, that's weird. And now I right click again and everything disappear. Okay, that's weird. But there's one problem first that I think we should fix is that even if we right click, we don't draw any paths. So I guess we can start with that, but we have to fix everything else. So let's go do that. And it's actually super simple. We can just go back in the action, find path to target. Inside the execute action, we never connected the path length right here. So I'm just going to take my variable and connect it like so. And that's it. Now the action should draw a path when we try to draw a path. Here we go, just like that. Now, if I'm inside the reachable and I try to draw a path, we can see that it works perfect. So now I'm able to draw a path, but that didn't fix this. Okay, we have to fix that. So why does that happen actually? Well, it's actually because we have two actors in the level that are attached to the same callback and they are doing opposite behaviors. They are fighting each other and that's the result. It's a big mess. So none of them really wins. It's just like Yeah, it's just a big mess. And if you look inside your action, select tile and find path to target, both of them are attached to the on pathfinding completed callback, this one right here. And in the find path, I have it right here. So both of them are attached to the same callback, and both of them, they have a function attached to it. So that one right here, which is trying to add the state is in path, and the same thing happened inside the select tile and unit right here. On the pathfinding completed, it tries to add the reachable state to all the tiles. So both in the case that we are trying to find a real path, or in the case that we are trying to find the reachables, it's also going to call this callback right here, this function right here, which is going to add the reachable states. And same thing for that one right there. In both cases, those two functions are called at the same time, and they are fighting each other to decide which one they are going to add on top of the grid. And that's just one example, but I'm pretty sure that there's a bunch of little other places that the code breaks just a little bit, nothing really major for now, I think. But every time we are generating the reachable, it also calls the pathfinding completed callback. So everything that is attached to that callback probably doesn't work as expected every time we are generating the reachables, because they are not really going to serve the same purpose. The reachable tiles are just for displaying reachable tiles, but the real path is going to be used to move the units around, or just highlight the path on the grid, or things like that. So they are both completely different from each other. They are doing the same thing, they are pathfinding, but in the end, the path that is returned by the function is not the same thing. If we don't change that, if we try to move the unit on the grid right now, it's probably going to try to follow the reachable tiles, all of them. That's pretty weird. That's not what we want. So I think we really need to fix that. And there's probably a bunch of different ways we can fix it, but I'm just going to go lazy and create a second component. So we're gonna have one component, one pathfinding component for the real path, so all the logic and everything. So we're going to keep the same component that we used since the beginning of the series, but we're also going to have a second component just for the reachables. That way, we are going to be able to bind ourselves to the component that we want to receive the message from and execute the proper logic. And that component is inside the BP grid. So I'm just gonna go here and open the BP grid, and then I'm just going to duplicate the grid pathfinding component that we have as child actor right here. So duplicate. I added underscore reachables at the end of the name because we're just going to use it for the reachables, and we're going to do the same exact thing that we did right here for the original grid pathfinding component. So inside the construction script, we are setting a variable using the child actor. So that's what we're going to do. We're going to do the exact same thing for the other component this time. And that's how it looks. So here I'm using the new component, not the old one. I'm using the new component that we have right here, and then I'm casting it as usual, and then I'm setting it inside a new variable. So I created a new variable right here, which is grid pathfinding underscore reachables, and I'm setting it right here and setting the grid as usual. And now we should simply be able to go back inside the action for the reachables and hook ourselves to that callback instead of the previous one. So I'm just gonna go back in there, and I'm gonna go inside the execute action function in the generate reachables right here, and I'm going to replace the grid pathfinding right here and the grid pathfinding right there with the new grid pathfinding underscore reachable. Just like that, and now this new action, the generator reachable, is now using a different component than the find path to target. That way it should fix all the problems. So now I'm just gonna go try and see if it worked. And I think it did. So yeah, inside the area where we can walk, so inside the reachables, we can draw a path if we want to, and if we move around, we can simply draw the path inside the reachables. When we are outside the reachable, the path just doesn't work because we can't reach that place. So perfect, we have all the basics we need to move the unit. But I think before doing that, I want to fix that little bug right here. We have still a path drawn even though we are selecting another tile, so I think it will be a good idea to just deselect the path in the case that we are selecting a new tile. So I'm just going to go fix that real quick. It was not planned, but it's not pretty, so let's fix that. And to fix that, we need a way to notify the action find path to target every time the selected tile changes, and it's not possible right now. So we're gonna need to create a new callback inside the player action. So player actions, and we can create a new event dispatcher. I named it unselected tile changed, and I'm passing it an index as input, so it's an endpoint right here, and we're going to call this inside the selected set selected tile and unit function right here. and we're going to do that every time we are changing the index. So right here and right there. So I call the callback right here, and actually I'm just going to connect it like so, and we can feed it the index, so the selected tile index. And now that we have the callback, we can go back inside the action and go in the event graph to hook ourselves to it, which we can do just like that. So on begin play, we are binding ourselves to the onSelected tile changed event, calling this event in return, and which is going to call the execute action again, but this time passing it an invalid info, so it's just going to hide the path. And now let's go test this. Here we go. Now, if I select a path and I select another tile, we can see that the path disappears. Before selecting the new tile, perfect. We can now jump on the units for real. So now, what's the next step? I'm gonna start by adding a new unit on the grid just to see the current behavior. So now, if I select and move my unit, we can see that it selects the unit. And if I right click, okay, it doesn't do anything. If I select my unit, it doesn't show the reachable, so that's bad. And then if I right click, it doesn't do anything. So we have a few problems here. We're gonna start by the reachables, and then we're gonna try to see why we can't move the unit around. So let's stop and go do that. So let's start by the reachables. It's super simple. It's actually just because we're not using the right action. So I'm gonna go in my debug menu, in my actions, in my button right here. I have my button move unit, which I'm going to open, and inside it, I'm going to select the right action for the left click. So the select tile and unit, I'm going to replace it by select tile and unit and generate a reachable, just like that. So now I can compile, close the button, and now we should see reachables in game when we have a unit. But actually, it's not the case, and that's because inside the button action move unit, we're never setting the length of the path and things like that inside the action for the reachables, and that's actually pretty normal because we want to use the unit data directly. We don't want to feed it some random data. So what we're gonna do is change the select tile and unit for the reachables just so it also supports the usage of the units, not only feed it data just like that. So before doing all that right here where we are finding the path, I'm just going to check to see if the selected unit is valid, because we're going to use different data if the selected unit is valid compared that if it is not. So that's what we're gonna do right here. Right here we have the find path for the selected unit when it is invalid, and for the unit valid, I'm just going to copy those nodes right here because we're gonna keep that, and we're just going to find the path, but we're going to use the unit data for all the other variables. Just like that, we are accessing the unit data of the selected unit, and we can use it to feed the function, just like that. For the delay and max milliseconds, we don't care about those, so we can leave it to 0, but right now we don't have the path length inside the data, so we're just going to go add that. So let's go back here. I'm gonna go in my units folder in utilities and open sunit data stats and create myself a new variable for the amount of movement point the unit currently has. I named it mp_current, and I've set it to 3 by default. Now I can save and close this structure, and I'm gonna go inside my data table just to add default values for all my units. So here what I did is just my ranger has 5 movement point, my priest has 4, my slime 3, chicken 10, bat 3 also, and my warrior is 3 by default because it is a basic unit. Now we are able to go back inside the action. We now have the new variable that we can connect to the path length, and now everything should work, I think. So let's go see if it works. Here we go. So now if I select my units, they all have a different movement points amount. We can see that it seems to work, but now I'm not able to move them still. So we have to fix that also. Let's go do that. And that's gonna be inside the action move unit on grid. So I'm gonna go in my actions in Pathfinding and find my action move unit on grid right here. And that's just because inside the execute action function at the end right here, we're never feeding it the movement point count. So we can just feed it like so, and now it should work as expected. And now if I select my unit and try to move, we can see that it works perfectly. I'm now able to select all my units and move them, and they are limited to the range they are assigned to. So here I have a certain amount of movement point, and I cannot exceed that amount of movement point. Here we go. So now it works perfectly, we now have a limited movement on our units. There's just a little problem right here that the movement range doesn't update every time we are drawing a new path. So every time I'm moving a unit, the movement range still stays visible and doesn't update. We have to select the unit again if we want to redisplay the reachable. So that's not good. So let's go fix that real quick. And we're also just going to make sure that when the unit starts to move, we are hiding the reachables, and when the unit stops to move, stop moving, it's done moving, we're just going to regenerate the reachable. That way, we are already going to be ready to generate a new path right away. So let's go do that. So first thing first, we're gonna need a new callback inside the unit to know when the unit starts moving, because we already have a callback for when the unit finished walking, but we don't have one for when it starts moving. So let's add a new event dispatcher for that. I named it on unit started walking, and I'm passing it the unit as input right here in top right corner. And what I'm gonna do is just go when we are starting to walk, so in the follow path right here before starting to walk for reals, and call this new callback. So call it right here. And for the unit, we can simply call it using a self, because this is this unit that is starting to walk. Perfect. We can compile that and go back in the action select tile and generate the reachables. And here what I did is just hook myself to the on unit started walking and unit finished walking right there before calling the find path function right here. We are hooking ourselves to those events, and we can create a matching function for both of them. So create matching, create a matching function, just like that, and rename them for sure. The first one is the on unit started walking, so when the unit starts walking, and it is simple, we can simply call the clear state from tile, passing it the is reachable. That way we're just going to clear all the reachables when the unit starts walking. And for the second one, on unit finished walking, it's as simple. We just have to regenerate the reachable, just like that. So the unit's done walking, we just regenerate the reachables again in the case that we want to move again. And I think that's it. We can now go test this. Okay, now I have my chicken and I can try to move it on the grid, and you can see that it works. When I start moving the unit on the grid, the reachables are disappearing, letting only the path visible, which is great. And also the chicken walks, and once it's done walking, the reachables reappear, so we know where we can move, which is pretty useful in a game in which we are moving units on the grid. So that's great. The feature seems pretty complete, and I'm pretty sure we're done with everything I was planning to do today, so great. But sadly, there's a little bug I want to fix before ending the video. I know it's a pretty long one, but I've seen that bug in a few videos already, and now I want to fix it. And it's actually that we are able to spawn a unit that should not spawn on a certain type of tiles. We are able to spawn them. So let's say I'm trying to spawn a ranger on top of the flying unit only tiles. We can see that it is possible to do it, which should not be the case. We should only be able to spawn the flying units on top of the flying tiles. And it's actually the same thing in the case that the units are already on the grid. So right now they are all on the normal tiles, which makes sense. If we are removing the tiles, we can see that the unit disappear with the tile, so that's great. But then if we try to set the tile type of those tiles to flying, these units are now still on the flying tiles, and that's not good. We have to fix that also. So we're gonna fix all that before finishing the video. So the first place we're gonna go fix that is inside the action that adds the unit on the grid. So I'm gonna go in action, combat, and action add remove a unit from combat right here. And right here at the beginning of the function, we can see that we are checking if the tile is walkable, but that doesn't mean that one specific unit can walk on that specific tile. So instead, we're just going to compare to make sure that the unit can walk on that tile before spawning it. And that's how I'm doing it. So I'm getting the default data from the unit type that we are trying to spawn at the moment. And from the valid tile type, we're just going to check if the valid tile type contains the tile type of the unit tile on which we are trying to spawn the unit. Perfect, that should work. We just have to go fix all the other places which are related to the grid regeneration. So when the tile type changes while the unit is on it. and that's inside the combat system. So let's go in there. I'm gonna go in my combat system right here, and we have two functions, so the on-grid generated and on-tile data updated. So on-grid generated first. And here same thing, we're gonna replace the isTile walkable by the check using the tile types. So let's do that. And that's how it looks. It's not pretty, but I'm pretty sure it should work. And now we're gonna go do the other function, which is the on-tile data updated. So let's copy all those nodes and go in there to replace the isTile walkable also. And here we go. Well, that's done. I know it's not pretty. It's the same as the other one. It's not pretty at all, but I'm way too tired to fix that tonight. So we might fix that in the future, maybe. Or not. I don't know. We'll see. Anyway, now we can go try that and see if we're done for the day. So now if I try to place a ranger on top of flying unit style, we can see that it doesn't work. Same thing for all the other ones. So the chicken, the bats are able to spawn on them. So that's good. It didn't break this. So that's perfect. And now if we try to change the tile type for a flying type, so flying unit only, we can see that the rangers are now disappearing. Same thing for the chickens because they should not be able to be on those tiles. Great, that feature works. Good. Boom, we're finally done for the day. Great, so I'm just gonna go sleep and I'm gonna see you in the next one. Bye bye.